All right, this is homework number 23. The first problems are just quick. It says state where the power series is centered. So remember, the center is just what you're seeing in parentheses, the x value raised to the n. So the center is just if anything is being subtracted from the x, that's the center value. So if we just have x to the n right here, the center would just be 0 because that would have been like x minus 0 to the n. Same here. It doesn't matter what the rest of the expression is saying. All this stuff in regards to n does not have to do with the center. That just controls what values you're going to get for the coefficients in front of each term. This one is x minus 2 to the n, so c is 2. If this would have said x plus 2 to the n, then the center would have been negative 2. And this one says x minus pi to the 2n. Now, that's still centered at pi, so the 2 doesn't mess anything up because that could be x minus pi squared times x minus pi to the n. This just means that or plus that, but this just means that all of the exponents are going to be even, kind of like our cosine power series. So the center is still pi. All right, the next section says just find the radius of convergence for the power series. So not the interval of convergence. And the reason I'm pointing that out is because sometimes if I don't read the directions carefully enough, I will do the whole thing and find the interval of convergence, and I'll be checking the endpoints and trying to see if it converges. But the radius is just when you get it down to x minus c is between the same number, it should be the same number on either side, that number is your radius. And then you can stop there. They're not asking about whether or not the ends should be included. Okay, so knowing that, for number 5, this is not geometric, so I'm going to do the ratio test to see what I'm left with. So the limit as n approaches infinity of the absolute value of x to the n plus 1 over, this will become n plus 2, divided by the nth term, which is multiplied by n plus 1 over x to the n. And what would we have left if we cancel out x to the n over x to the n plus 1? We would just have x to the first power. So you don't have to rewrite this limit. I'm just doing it to make things look a little more clear. So we just have an x up here times an n plus 1. And in the denominator, there's just an n plus 2. And remember, when you're taking the limit at infinity, you're not plugging that in for x. You're just thinking about how the expressions involving n will be changing. So n plus 1 over n plus 2 approaches 1. So we're left with 1 times x, or just absolute value of x. And so this series would converge by the ratio test if the absolute value of x is less than 1. And we did this previously in the chapter. That means that x can be anything between negative 1 and 1. And because I already have the x minus c, which in this case is just x minus 0, I already have that isolated. So I've got the radius showing right now. The radius is equal to 1. The ends of the interval, whether they're included or not, are 1 unit away from the center. All right, for the second one, now this could be rewritten as a geometric sequence, a geometric series, because all of these are to the n power, so that means you can put them all to the nth, and so this would be negative x on top, 5 on the bottom. So this is a geometric series, and that means that this would, I can just get right down to saying converges by geometric series test, so I don't have to do all the limit stuff. So the rule for the geometric series test is as long as r is less than 1 in absolute value, then the thing converges. So, excuse me, so the absolute value of negative x over 5 is supposed to stay less than 1. So taking the absolute value of that just makes it x over 5. And so we're just saying that needs to be between negative 1 and 1. Now, this is not in the form of x minus c yet, so I don't yet have the radius. I need to multiply the 5 out. So now it's in the form, you want to get the x minus c by itself. Again, x minus c is x minus 0 here. So now I can see that the ends of the interval of convergence are 5 units away from the center. So r is equal to 5. You could also have done ratio test for this. It's just a matter of not wanting to go through the limits, so I just chose geometric series test. I can't do geometric series test on the next one because I can't just lump this entire expression together to the n power. So this one has to be ratio test. So this is going to be the limit as n approaches infinity of the absolute value of, so remember this is 2 times n plus 1 when you plug that in. So that's 2n plus 2 factorial. Same thing here. This is going to become x to the 2n plus 2 because you're doing 2 times n plus 1 quantity. Down here, we'll just have n plus 1 factorial. Divided by the nth term, so multiplied by the reciprocal of the nth term. So times n factorial over 2n factorial times x to the 2n. Now, there are all kinds of things to cancel out and rewrite, so I think I am going to rewrite a cleaned up version here of what's left. Let's just start with the x's. 2n plus 2 minus 2n leaves me with x squared in the top, so I've got that up there. And then what about all of the factorials? So let's start with n plus 1 factorial is n plus 1 times n factorial. So the n factorials cancel, so there's an n plus 1 in the bottom. 2n plus 2 factorial is like 2n plus 2 times 2n plus 1. You're just subtracting 1 for factorials. Times 2n, and then that'll be factorial after that. So 2n factorial cancels with 2n factorial. And in the top, you will have 2n plus 2 times 2n plus 1. So now we have, for the n's, we have a degree 2 on top and a degree 1 on the bottom. So that means that even though the x squared doesn't get an infinity in there, this becomes infinity times x squared. So this series actually diverges by the ratio test, except remember there's one little caveat. If you plug in the very center, remember the center, a power series will always converge at its center. And the reason for that is because when you plug the center in, you're just making the terms equal to 0. So think about this. The center is 0. If I plug in a 0 for x right here, I'm going to just be getting the sum from 0 to infinity of just 0. 0 times 2n factorial over n factorial is 0. So this series diverges by the ratio test for all x except the center, x equals 0. Now, what does that mean about the radius of convergence? Because that's the question. So if your interval of convergence is only one single number, it just means that the radius of convergence is 0. You can't stray at all from the center to get this thing to converge, whereas on the previous one, I could stray 5 units from the center in either direction and get something that converges. Okay, let's take a look at the next section. So I added these problems, by the way, so this might be different than the assignment list I gave you. I moved these problems from assignment 24, which was much longer than this one, to this shorter assignment. So just to practice these. So find the interval of convergence of the power series. Be sure to check for convergence at the endpoints. So these are pretty commonly like free response questions. You need to show that you're checking the ends, even if you could have done it in your head. The only time you don't have to check the ends would be if you're given something that's geometric. So take a look at this first one. I don't have to use ratio test for this one because this is a geometric series. So I can get right down to saying this converges by the geometric series test. And that test doesn't allow r to equal 1. It says that the r in absolute value needs to stay less than 1. So I'm not going to need to check that the ends work because I'm not supposed to include them. I can't let this equal 1. It would give me a series of either 1 to the n or negative 1 to the n if I do that. So, all right, so solving for this, that means that x over 4 can be between negative 1 and positive 1. And if I multiply the 4 over, I get that x can be anything between, but not equal to, negative 4 and 4. And that would cause this, think about what that's saying, that would cause this to be a fraction less than 1. So that's going to converge by our geometric series test, right? Like this could be 3/4 or 3.9 over 4. All of that, as long as it's less than 1, you'll get something that converges. So I'm not checking the endpoints on this. Follow-up question, I wasn't asked this, but just to practice, the radius is 4 for that. Okay, for number 14, I can't use a geometric series test on this one because there are some n's that are not being raised to an n power. So instead, I'm going to use ratio test. It's the limit as n approaches infinity of the absolute value of, so this will become n plus 2 times x to the n plus 1 divided by n plus 1. I don't need a reciprocal here, over x to the n, since this expression is not rational. So what does this come out to? Well, the n's are approaching 1, and the x's, when you divide them out, you're just left with x. So we're back to just getting the absolute value of x. And so this series would converge by the ratio test if absolute value of x is less than 1, which means x can be between 1 and -1. Now, this was not geometric, so I do need to double check the n's. And again, even though you might just be able to kind of do it in your head, I want you to practice this skill for the AP test. Because if we get this in free response, it's not going to be something that we can just kind of look at and do in our head. Or even if it is, they want to see what happens. What series do you have when you plug in -1 or +1? All right, so here's something to practice. So it's -1, oops, there's no fraction, so I'm going to put it down here. So -1 to the n plus 1 is in there already. N plus 1 is in there already. And we're saying this is for x equals -1. We're going to plug -1 in here, which will give me a -1 to the n. So here's the skill that I would like you to practice. You are allowed to add the exponents of these two expressions because they have the same base. So this simplifies to, from n equals 0 to infinity, you've got to have all your notation. This would be -1 to the 2n plus 1. I just added those expressions together, times n plus 1. So I already know nth term test before I even did that this is not, n plus 1 is not approaching 0. So this is going to diverge. But again, I just want you to practice this skill. 2n plus 1 is always odd. So you're always going to get -1 to an odd power, which means this would really just be the sum from 0 to infinity of just -1 times n plus 1. There's no real need to have the 2n plus 1 expression. So just the fact that you recognize that is important because that's something that will matter when we do this on an AP test. Now, all of that is to say, and I could have said back from line 1 or just by looking at it, this diverges by the nth term test. So we are not including the endpoints, -1. And so we do the same thing to show the work for what if x equals +1. Again, you might already know the answer to this, but we're just kind of practicing our free response skill on this, like what will we have to do. So I would be plugging in +1 for x. Now, +1 to the n, here's another thing to practice. Make sure you're not making this mistake. I'm not adding the exponents in this case because I don't have the same base number. I have -1 and +1. So 1 to the n is just 1, right? So we don't really need to show that we're multiplying a 1 in there. So I can get down to nth term test right away on this because this is alternating, but the terms are not approaching 0. So this little series diverges also by nth term test. Usually on a free response, they'll say something like, you're getting maybe a point for doing the ratio test correctly. You're getting a point for probably showing like this series. And then you're getting a point for correctly having the endpoints included or excluded. So in this case, we're not including either of those exponent or either of those endpoints. So the original interval I got is my final answer. I don't have to include an equal to sign on either of those. All right, let's take a look at number 17. On 17, I broke this up into, instead of x over 3 to the n, because I'm using ratio test with the factorial involved, I'm splitting it into x to the n over 3 to the n. Just to make, you don't have to do that, but it just, for me, it makes the canceling easier to follow. So 2n factorial becomes 2n plus 2 factorial. X to the n will become x to the n plus 1. and 3 to the n will become 3 to the n plus 1. So that's just why I like splitting it up. We're multiplying that by 3 to the n over 2n factorial times x to the n. All right, so things cancel, right? The x to the n cancels here and gives us x to the first. The 3 to the n cancels here and gives us 3 to the first. And 2n factorial will cancel with 2n plus 2 factorial, but you'll be left with 2n plus 2 times 2n plus 1. And again, I kind of spelled out that canceling in the first problem. So if you need to go back earlier in the video to see more of an explanation on that, you can. All right, so I'm going to rewrite this so that I can see what's left, especially if I'm doing an AP free response question, I want my work to be nice and clear and easy for the grader to follow, because if they can't follow, they're not going to give me credit for it. So we don't want to be too lazy about this. All right, and then what's happening with this one? Well, there are only n's on the top. There's no n on the bottom to negate that. So this is going to infinity, which means that this series diverges by the ratio test. For all x except, remember, the center works. We can plug in 0. The center here is 0, and we would get something that converges, because it converges to the sum of 0 if you're just adding 0. So except x equals 0. So what is the interval of convergence? It's just x equals 0. It's not really an interval. Okay, and the radius, by the way, would be 0. Radius for this one would be 1. Okay. All right, what about the next one? It says find the radius of convergence where c is greater than 0 and k is a positive integer. That's for number 36, which we're not doing today. All right, so now this could be geometric. I could write this to the n minus 1, but with the n minus 1, that's kind of weird to me as far as geometric goes. I don't know if that would, off the top of my head, I can't decide if that would really apply or not. So I'm just going to be safe and do the ratio test, because ratio test should work every time, even if geometric would have worked. So when I plug in n plus 1, this becomes x minus c to the n over c to the n multiplied by c to the n minus 1 over x minus c to the n minus 1. All right, and then careful when you subtract your exponents here. N minus the quantity n minus 1 leaves you with 1. And down here, n minus 1 minus n leaves you with negative 1. So let's rewrite what we have. It's the limit as n approaches infinity of the absolute value. So the x minus c's are going to be to the first power. So x minus c is on top to the first. And then on the bottom, it's c to the negative 1 on top, I should say. So then that sends c to the first on the bottom. And there are no n's in this expression. So what is the limit as n approaches infinity? It's just x minus c over c. So this will converge by the ratio test if the absolute value of x minus c over c remains less than 1, which means negative 1 is less than x minus c over c, which is less than 1. I multiply the c out to either side. Negative c is less than x minus c, which is less than c. So by the way, r is c right here because I've isolated the center. Okay, and then solve for the interval. So add c from the middle to both sides. You get 0 is less than x, which is less than 2c. There was a stipulation that c is greater than 0. I think that's just so that this inequality stays true. If c becomes negative, then it flips this inequality around. So, okay, so x can be anything between 0 and 2c, and then we need to check the endpoints of that. So checking the ends, we're saying, I'm going to do the checking, I'm going to check over here. All right, so let's check if x equals 0. So if we check 0, we get the sum from 1 to infinity. Oh, wait, No, see, here I am. I don't need to do that. Find the radius, not the interval. So I didn't actually need to do this. The radius was C. Sorry. And now you could, back here, you could say, wait, how is it C? Because we're going from like distance from C to C seems like it's like 0 or something. But this would just be like, if C is the center, 2C is 1 unit away, or is 1C unit away from that. 0 is 1C unit away from that. Or if it helps, make them numbers, like assign a number to C. So we're going from X minus 2 to 2. You're saying like you have a distance of 2 on both sides here. It's 2 units to the right from what would make this 0, and it's 2 units to the left. So I don't know. If that's confusing, just don't overthink it. You're just using this number that's on the end here. Okay, last two problems. Write an equivalent series with the index of summation beginning at n equals 1. So anytime we see problems like this, don't overthink it. You're not really thinking hard about a pattern. What you should do first is go ahead and expand the terms out using the n's they tell you. So start at 0. I usually do maybe 3, maybe 4 if I'm not seeing a pattern clearly. Terms just to get myself started. So plug 0 into this and don't simplify anything. So leave it as x to the 0 over 0 factorial, because you're looking for patterns, plus x to the first over 1 factorial, plus x squared over 2 factorial, and I think I'm okay. I'm going to stop there. So the question just says, instead of starting at 0, say you get this term, but you plugged in 1, and you get this term, but you plugged in 2, and you get this term, but you plugged in 3. So how would you have to adjust the expression? So the summation would go from 1 to infinity. So what is this now? So now the power is 1 less than the n value. So it would just be x to the n minus 1. And the factorial is also 1 less than the value of n. So it would just be over n minus 1 factorial. So I never really think too hard about shifting or has this gone right or left or whatever. I just expand out the terms and then write the numbers that I'm supposed to have underneath them and use that to create something new. So I'm going to do the same thing with this one. Let's start with just plugging in, because it says 0, 0, and then 1 and 2, and see if that's good enough. All right, so if I plug in 0, I get negative 1 to the first, which is negative 1. 0 plus 1 is 1, and x to the 0. Again, don't simplify anything because you want to have the correct pattern in the next part. So then plus negative 1 to the, I guess the only part I'm simplifying is whether it's plus or minus. So negative 1 to the second will be plus 1, times 1 plus 1 is 2, times x to the first. And then it should be minus, right? Negative 1 to the third is minus 1 times 3 times x squared. All right, so now change this so that this is supposed to be what you get when you plug in 1 and 2 and 3. So now the series will go from n equals 1 to infinity. It's still negative 1 to a power, but n plus 1 doesn't work anymore because n plus 1 would make this positive 1. So I think the odds are negative, right? And the even was positive. So I think I can just say negative 1 to the n to take care of that. And then the number inside of the parentheses is now the exact same thing as n instead of n plus 1. So it's just times n. And the exponent on the x is 1 less than n, so x to the n minus 1. All right, that finishes this assignment. Let me know if you have any questions.